The universe is trying to kill your warmth. Not with fire, not with impact, not with radiation tearing through your cells. It is doing something quieter, something older, something so fundamental that most people never even think to be afraid of it. It is doing it right now, at this exact moment, just a few hundred kilometers above your head. The universe is pulling heat away from everything that exists, draining it slowly, inevitably, into a silence so complete that the word cold stops meaning anything at all. That silence has a number, 2.7 Kelvin. That is the baseline temperature of open space. Not the temperature of a planet, not the temperature near a star. The temperature of the universe itself, measured in the vast, unlit corridors between everything you have ever seen or imagined. And when scientists first calculated that number, some of them felt something they did not expect. Not scientific satisfaction, something closer to dread. Because 2.7 Kelvin is not just cold, it is almost nothing. It is the last whisper of heat left over from the Big Bang, spread so thin across 93 billion light years of expanding space that it barely registers as warmth at all. The universe was born in an explosion of unimaginable energy, and this faint dying trace is almost all that remains of it. But here is the part that most people get completely wrong. When you imagine the cold of space, your brain reaches for familiar references. You picture Antarctica, -40, -60. You picture frost forming on metal, breath turning to vapor, fingers going numb within seconds. You picture cold as a thing, as something that moves through the air and presses against your skin. That picture is wrong, completely, fundamentally wrong. Cold is not a thing. Cold is an absence. It is what remains when heat has been removed. And on Earth, even the most brutal winter, there is still something present to carry that coldness. Air molecules, wind, humidity, matter pressing against your body and pulling thermal energy away from it. That is why Antarctic air feels unbearable. The matter around you is stealing your warmth faster than your body can produce it. Space does not work that way. Space is not cold the way a freezer is cold. Space is cold the way a room with no walls, no floor, and no ceiling is empty. It is not that the temperature is low. It is that there's almost nothing there to have a temperature at all. In the vacuum between stars, you could travel for light years and encounter perhaps a single hydrogen atom per cubic meter. One atom per cubic meter. That is not thinness. That is near total non-existence. Imagine you are standing outside on the coldest night your city has ever recorded. The air bites. It pulls heat from your exposed skin in milliseconds. Now remove the air. Remove every molecule around you. There's no longer anything pressing against you, stealing from you, transferring anything at all. In that vacuum, you would not freeze instantly. You would actually survive the temperature of space far longer than most people expect, not because it is warm, but because without matter, heat has almost no mechanism to leave your body. Radiation would slowly carry it away. But convection, conduction, the paradox of space is that the absence of matter that makes it so cold is also the very thing that slows the process of you becoming cold. The universe is strange like that. It kills you, but slowly, and not in the way you imagined. Now stretch your perspective further. Because 2.7 Kelvin is not even the whole story. Space is not uniform. Space is not one temperature any more than Earth is one temperature. The universe has geography, thermal geography, and when you begin to map it, the picture becomes extraordinary. Near a star like our Sun, temperatures in the surrounding corona reach over 1,000,000 degrees Celsius. 1,000,000. The surface of the Sun itself burns at roughly 5,500 degrees Celsius, hot enough to vaporize any known material in an instant. But move just a few light hours away from any star, step into the interstellar medium, the space between solar systems, and that roaring furnace becomes irrelevant. The background temperature drops toward that baseline, 2.7 Kelvin, the cold of the cosmic microwave background radiation, the thermal fossil of creation itself. But even that is not the coldest place we know. In the Boomerang Nebula, roughly 5,000 light-years from Earth, temperatures have been measured at 1 Kelvin colder than the average background temperature of the universe. A dying star expelled gas so rapidly, so violently, that the expansion cooled it below the cosmic baseline, a place in space that is colder than the universe itself, colder than the afterglow of the Big Bang, colder than almost anything that occurs naturally anywhere in existence. 1 Kelvin, minus 272 degrees Celsius, 1 degree above absolute zero. Absolute zero is 0 Kelvin, the point at which molecular motion theoretically stops entirely. At absolute zero, atoms cease to vibrate. Energy ceases to transfer. Time, in a sense, stops mattering for matter. No natural object has ever reached it. Physics suggests nothing ever will, but the Boomerang Nebula sits at 1 Kelvin, close enough that the difference feels almost philosophical. We have never built anything that cold on Earth. The coldest temperatures achieved in human laboratories required extraordinary effort. Magnetic cooling, laser manipulation of individual atoms, technologies that would seem like science fiction to anyone from a century ago. And even those experiments reached temperatures measured in millionths of a Kelvin above absolute zero, only briefly in spaces smaller than a pinhead. The Boomerang Nebula is a nebula. It is light years across, and it sits colder than almost anything humans have ever achieved on purpose. But the real question, the one that sits under all of this, is not how cold space is. It is what that cold means. Imagine the Earth from orbit, a sphere of blue and white, impossibly thin atmosphere clinging to its surface, oceans and continents drifting below. From that distance, every human being you have ever known is invisible. Every city, every civilization, every fire ever lit, every star ever navigated by, compressed to a surface thinner than the skin of an apple. That thin layer is warm, absurdly, miraculously warm. The average surface temperature of Earth is roughly 15 degrees Celsius, 288 Kelvin, set that against the 2.7 Kelvin of surrounding space. And the difference is not just numerical. It is almost insulting. Earth is a burning ember floating in an ocean of cold so profound that the ember should not exist, should not have lasted, should have been swallowed by the silence a billion years ago. And yet here we are. Here is the part that reshapes how you see all of it. Heat is not the natural state of the universe. Warmth is the anomaly. Cold is the default. The universe began in fire, a singularity of incomprehensible temperature and density, and it has been cooling ever since. Every star that burns, every planet that radiates warmth, every living body that generates heat is a temporary rebellion against the direction the universe is traveling. You are warm right now. Your body maintains a temperature of approximately 37 degrees Celsius, 310 Kelvin, through a constant biochemical process that began billions of years ago in the first cells that figured out how to convert energy into structure. Every heartbeat is the universe briefly defying its own trajectory. Every thought you have, every memory, every moment of love or fear or wonder, all of it is thermal. All of it is heat, and the universe is slowly, patiently, inevitably taking it back. Stars will not burn forever. The most massive ones will explode in supernovae, scattering elements across the galaxy, seeding new solar systems, new planets, new possibilities. But eventually, even that cycle ends. Stars will exhaust their fuel. Smaller stars will cool into white dwarfs, then black dwarfs, cold, dark stellar corpses floating silently through space. Galaxies will spread apart as the universe continues expanding, the distances between everything growing so vast that even light from neighboring galaxies will eventually redshift beyond detection. Scientists call the endpoint of this process the heat death of the universe. Not death by fire, death by cold, a state of maximum entropy in which all available thermal energy has been so evenly distributed across such unimaginable distances that nothing can happen anymore. No gradients, no reactions, no stars, no planets, no warmth.